Welcome back. Thought we'd do something a little different, a little more fun, perhaps not, for the final video in this series. We'll start out with housing prices version 12. And again, like we did with means, we'll try and utilize some of the work that we've done before. So I'm going to highlight, first of all, let's save it. I'm going to save this as version 13, lucky 13. Kind of a good way to end this particular set. And then I'm going to highlight hypothesis test for part 1, click on the plus, and paste this in for part 2. Make it a little bit bigger, label it great. Now, here's the context. We're going to estimate based on a sample whether our candidate will win an election. So at least in the United States, in order to win an election, you need to get more than 50% of the vote. Not exactly 50, not close, more than 50. And we'll assume a 2-candidate race. So people are voting for 1 or 2 candidates. And even if they vote for a 3rd candidate, the winner still needs to get more than 50%. So that means my alternative, or my null hypothesis, is less than, and my alternative hypothesis is greater than. And we're going to, again, utilize most of these. So alpha level still 0.05, but we'll start with a sample size of 100. And just for ease, we'll say 55 people that we surveyed responded positively to our candidate, which created a sample proportion of 0.55, which is higher than our hypothesized 50-50 of 0.5. I see the standard error actually in this case works out to be almost 5% exactly. All these formulas work nicely. Now here, we are only concerned about the positive side, which means we don't need to split the alpha into both sides, but we can take care of that, divide by 2 here. And that makes our critical z value 1.645. And we can get rid of it here as well. So we only need to have a z value greater than 1.645 in order for us to reject the null and potentially conclude that our candidate will win the election. Our test statistic still looks the same. Our sample proportion minus our hypothesized population proportion divided by our standard error. We also note at this point that it's only 1, which is not greater than 1.645. The tail area for this is still to the right, and this formula still works. Of course, since it's a one-sided test, we only need to multiply by 1. So now we can evaluate this. Let's get rid of the text from part 1, and we would say we do not reject HO because the test z value of 1.005 is, emphasize, a not greater than 1.645, and the p-value of 0.1574 is not less than alpha, spell it right, alpha of 0.05. Therefore, there is not enough evidence to conclude, or not enough evidence to show, that the population population proportion of voters is greater than thus we cannot predict that the candidate will win the election. So interesting insights in here. We're not saying that they're going to lose the election because they have 55% of the sample vote. We just are saying we don't have enough evidence that they will win the election. But now we have an interesting tool. And of course, elections are big business these days. We can try something different. What if we took a larger sample size and doubled it to 200, and we still had a sample proportion of 55%? We have to double that. Now we're getting close. We're down to about 7 or almost 8.08 p-value. Well, let's double it again. Let's try 400 sample size. Still, the sample proportion is still 55%. However, because of the larger sample size, we've shrunk our standard error in this case now by almost half of where we started. Our p-value is now down to 0.02 and change. And in this situation, we would conclude that the candidate would win the election, and we'd be pretty confident about it. If for some reason we had the resources to survey 1,000 potential voters, that drives our p-value all the way down to 0.007%. That's a very strong result. So in this case, we would reject HO and conclude that the proportion of voters was greater than 0.5. And we would do it with quite a bit of confidence. And I believe our candidate would be very happy because we would confidently predict that they would win the election. And so that's a lot of insight. Let me go back to the original 55 out of 100 here, just to leave it so you can kind of play with it. But this tool allows us to explore different levels of sample size and see how it impacts. When we started with a sample size of 100, our p-value was well above 0.05, and I wouldn't want to risk telling our candidate they were going to win.